Okay, let's do the next, that is the seventh one. That is a equal to x, set of all x such that x is a natural number. Okay, here x is all the natural numbers, and the b set is all the x's are even natural numbers. Okay, it's even numbers. Okay, and set c is all the odd natural numbers. Okay, and d is prime numbers. Okay, so now these are given in set builder, so let's convert this to roster form. Okay, so a will be set of all natural numbers, so 1 2 3 4 5 6 so on. Okay, and b will be set of even natural numbers. Okay, natural numbers, but those are even, so 2 4 6 8 10 so on. Okay, now c is a odd natural numbers, so odd are 1 3 5 7 9 so on. Okay, and x is prime numbers. Okay, d is equal to prime numbers. Prime numbers are those numbers which are divisible by itself. Okay, by 1 and itself. Okay, and so it starts from 2. Okay, 1 is not a prime number. 2 3 5 7 11 13 and so on. Okay, so these are natural numbers. Okay, these are even numbers, these are odd numbers, these are prime. Okay, so the first question will be is a intersection b. Okay, a intersection b, so what are the common between them? You have 2, you have 4, you have 6. Natural numbers has everything, but common is only the even numbers. Okay, 2 4 6 8 and so on. So you can write 2 4 6 8 and so on. Okay, so these are even numbers, so you can simply write a intersection b equal to, because this is even numbers, a intersection b is equal to b. Okay, okay, you got the intersection b is all the even numbers, so here b is even numbers. Okay, so you can write a intersection b is equal to b. Okay, so second one, a intersection c. A and c, a are natural numbers, these are odd numbers, so here common is 1 3 5 7. Okay, so you have 1 3 5 7 so on, so all the odd numbers are common here, so you can simply write a intersection c is equal to c is the odd number, so a intersection c is equal to c. Okay, because you have all the common odd numbers. So third one will be a intersection d. A and d. Okay, this a and d, here it's prime numbers and here's natural numbers. So here common are 2 is common, 3 is common, 5 is common, 7 also will be common because natural number has save all numbers. Okay, 11 13, so you have all the prime numbers common, and also 2. Okay, so you can write this as, we can write all, so you will have all the prime numbers here, so 2 3 5 7 so on. Okay, so you can simply write a intersection d is equal to all the prime number, that is d, so we can write a intersection d is equal to d. Okay, so now we'll write the fourth one. What is the fourth one? B intersection c. Okay, b and c. B is 2 4 6 8 all even numbers, odd is c is all the odd numbers. Okay, so there is no element common here, because here is odd, here is even, here is odd, so there is no common element, so the set is empty. Okay, so we can write b intersection c is 5. Okay, empty set. Now you do the fifth one. Let's do the fifth one. Okay, fifth one is B intersection D. Now B is even numbers, D is prime numbers. Okay, so what you have here, you have 2 common, and the remaining all the prime numbers are odd numbers. Okay, so B is even number, so you have only one number common, that is 2. The only even prime number, that is 2. Okay, so we can write 2. Okay, that is only 2 is common. Okay, now we'll write the sixth one. C intersection D, which is equal to C and D. These are odd numbers and these are prime numbers. Okay, so odd numbers 1 3 5 7, even numbers 3 5 7 11. Okay, all the prime numbers are except 2 are common to this odd numbers. So 2 is even, so only the odd prime numbers are common. Okay, so we can write this as 3 5 7 11. Okay, 3 5 7 11 13, so on. So this can be written as C x such that x is an odd prime number. Okay, not all prime numbers is a prime, this it's an odd prime number because we don't have 2 is even. Okay, 2 is even, from 3 it starts, so odd prime numbers. X such that x is an odd prime number. Okay, that's it.